Hello everyone! In the video today we're going to look at the breakdown of differential equations in slope field free response questions and then answer two of them. Okay, so the question breakdown, there's really just like two major questions that they ask for these. It's usually the first question, create a slope field, so that's drawing it, and we made our own slope fields using the pipe cleaners. They turned out really good. And then find the particular solution. That's the most common question. Then there is find the equation of the tangent line and some other stuff, which is like miscellaneous other things. But really, if we look at the breakdown by point instead, finding the particular solution usually gets you 6 points. That's a lot of points. That's a lot of points. So if we can just do that, we're already in big business. And a lot of you are already good at creating slope fields, so that's 2 points. And there's only 9 points in a problem. Usually that other 1 point is for this like equation of tangent line and something. But this is the meat. If you can find the particular solution, you're going to get a lot of points on these questions. Let's do an example, but first let's go through the creating a slope field. There are just some common slopes that we need to know. We need to know these common slopes look like. And a reminder that you'll see differential equation problems written like this, dy dx equals something. But just a reminder that dy dx is the same as the slope of the tangent line because it means the derivative. So if dy dx equals 0, it means the slope of the tangent line is 0. So we would draw a slope 0 line, horizontal line. Likewise, if dy dx is equal to 1, then we would draw a slope of 1, increasing like a 45-degree angle. And if it's, well, that's supposed to be negative 1. Sorry, I have to fix that. If it's negative 1, it'll be decreasing. But we should know what will happen if we increase our slope to 2. Positive 2, it should be increasing at a steeper value, steeper amount. Negative 2 would be decreasing at a steeper amount. Then we should also know something between 0 and 1, like 1/2, what would happen? Well, it'll be between these two, between a flat line and between a slope of 1. It'll be increasing just a little bit, and this will be decreasing just a little bit. And I'm not going to go over right now the particular solution. It's better if we just do the problems, and then we'll go through the technique from there. So, here is a typical free response question. We have 15 minutes to do it. I think we can do it. Let's look at part A. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Okay, so the first thing I want you to look at is where the slope is 0. If we make x 0, then 0 times whatever that is 0. So along the entire vertical line x equals 0, we'll draw our horizontal little line segments. Then, if we look at this factor, if we say y equals 2, then dy dx equals 0 again. So on this horizontal line y equals 2, we'll also put our horizontal slopes. Then for the rest of them, we can just plug in the points. So plug in -1, 0, -1, 1, -1, 3, all these 6 other points into this equation, and then see what the slope is. So at -1, 0, we have a slope of -2, then -1. You can check my values, and you should check my values for sure, because sometimes I make mistakes. But that's part A. It's just drawing the slope fields, drawing the slopes. This is how it's scored. We get 1 point for each 0 slope, and then 1 point for each positive and negative slope. So it's 2 points in general. It's really 1 point for the 0 slopes and 1 point for the non-zero slopes. So the first set that we started with give you a point, and then the rest give you another point. I think that's usually a pretty quick 2 points. B, this is going to be, actually this is it's the hard question that's only worth like 1 or 2 points. So while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. So if it's negative, it means it's less than 0. But notice that If the product of two factors is negative, it means that they have to be different signs. X to the fourth and y minus 2 have to be different signs, one positive, one negative, if they are to be multiplied and give you a negative number. And x to the fourth is always greater than or equal to 0, and it's always positive if we say that x is not allowed to be 0. If it's not 0, then it's always going to be positive. That means y minus 2 has to be negative. So if we say y minus 2 is less than 0, we can solve and get y is less than 2. So to describe all points in the xy plane for which the slopes are negative, we could say slopes are negative at points xy, where x is not equal to 0, it could be anything else, and y is less than 2. And that's it, but we only get 1 point for that question. 1 point. And we're going to see this a lot. The slope field and finding the particular solution give you almost all the points. I would say skip this and then do it at the end if you have time. Because you have 30 minutes for the calculator section and 60 minutes for the non-calculator section. But that's 4 questions in the non-calculator section, so you can take as much time as you want for any of them. You can go back and then try it at the end for that extra 1 point. But it's not really the most important thing for this question. Alright, this is the big one. Find the particular solution, y equals f of x, to the given differential equation with the initial condition f of 0 equals 0. And again, the calculus here isn't the hard part. It's all of the pre-calculus algebra 2 steps that we're going to get stuck on. There's a lot going on in this. The first few steps, though, pretty straightforward. We rewrite the differential equation. We separate the variables. Get all of the y's on one side, all the x's on the other. Then we integrate. So far, it should look familiar. Separate, integrate. Now, this you can do substitution, but I want you to recognize that it's a linear factor on bottom. So if it's just a linear factor, we can immediately jump to natural log. Natural log of the absolute value, very important, don't forget absolute value, make a note of it, equals x to the 5th over 5 plus c. Now we can exponentiate both sides. When we do that, there's something special that happens on the left and on the right. On the left, we're composing a function with its inverse, so we just get absolute value of y minus 2, which is something I keep forgetting to do in class, so you need to yell at me when I do that. I forget to include the absolute values. On the right side, we can rewrite this as e to the x squared, x to the 5th over 5 times e to the c. That plus c comes down as a multiply by e to the c. Now we're doing something a little weird. We're saying y minus 2, getting rid of the absolute values, is equal to a e to the x to the 5 over 5, where a is equal to plus or minus e to the c. The plus or minus is coming from the absolute value. So when we get rid of the absolute value, we're saying y minus 2 could equal positive this, or it could be equal to negative that, because the absolute value would turn that into positive. So a is equal to plus or minus e to the c, and we do need to include this to get full credit. Then we add 2 to the other side. We're almost done. It's time to apply the initial condition. So we're about halfway done. We have a lot of points for this problem already. Let's finish it off. So we're applying the initial condition of f of 0 equals 0. So y is 0 equals a e to the 0 plus 2. E to the 0 is just 1, so we get 0 equals a plus 2. So a is negative 2, and our last step is to rewrite this with the negative 2. So y equals negative 2 e to the x to the 5th over 5 plus 2. Oh man. Okay, so a few notes, things to remember. Things that are easy to forget. 1, the absolute value when we integrate for natural log. 2, that the c becomes e to the c. 3, that when we get rid of the absolute values here, that we need plus or minus. In the A, or I think in the answer key they use K instead. Whatever letter we use, it's fine. And then the initial condition and rewriting your equation with it. There's a lot of tough stuff to keep track of. And there are some steps we can skip. This is the work that they expect. The minimum amount of work is this. Still a lot of steps, but they don't show as much work as we did. let's show what they did. So from the first step to the second, they took the antiderivative of both sides without showing the integral sign. Then they exponentiated both sides without showing e to the natural log. You can do that too. It's totally fine. And they took the c and made it out front e to the c as well. So they combined a bunch of steps that we had multiple steps for. Then they said y minus 2, getting rid of the absolute value, is equal to k e to the whatever, blah, 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 where k is equal to plus or minus e to the c. Then they applied the initial condition to solve for k, and then they rewrote. We get 6 points for this problem. 6 points, holy mackerel. If we separate the variables, 1 point. That was the easy part. If we take the antiderivatives correctly, that's another 2 points. So already we have half the credit for this problem in like 3 lines. If we remember the constant of integration, we get a 4th point. If we use the initial condition, even if we use it incorrectly, we get a 5th point. And then 1 more if we solve for y. But there are some notes. If we don't separate it, if we don't show the separation, then we get 0. But that's the easiest step to start with. Like we always start with the separation part. And we get a maximum of 3 out of 6 if we forget the plus c. But I know you won't forget the plus c. You'll never forget the plus c. You're too good at this. So this is a lot of points. We're going to get these points. Trust me, we're going to get a lot of these points. Remember, our goal is like 5 out of every 9 points. You're in very good standing to pass. You could get 5 points just from this problem. Like if you see the slope field and you don't feel comfortable with the slope field, just skip to this part. We can practice the math and you can get a lot of points. Alright, let's do one more. I'm going to go through this one relatively quickly. But it's the same setup. Let's look at the questions real quick. We have a differential equation and we want to write the slope field, then we want to write the equation of a tangent line, then find the particular solution with the initial condition. Alright, nothing really new here. Slope field. Negative xy squared over 2. This one, if x is equal to 0, then the slope is equal to 0. So on this vertical line, we get 3 horizontal slopes. Then if y is equal to 0, we also get 0 because they're being multiplied. So on the x-axis, horizontal line, we get horizontal slopes. For the rest of them, we're going to need to make, do the points, plug in the points, and see what we get. And please check my math on this. Negative 1, 1, we get a slope of 1/2. Negative 1, 2, we get a slope of 2. 1, 1, we get negative 1/2. 1, 2, we get negative 2. 2, 1 is negative 1. And 2, 2 is negative 4. And this is only 2 points. 1 point for the 0 slopes, which is nice. The 0 slopes are always the easiest. And then 1 point for the non-zero slopes, just like the other problem. It's 2 points, and you should do this part because it is easy points. You're good at it. It's easy relative to the other questions that we've dealt with in the past. Okay, write an equation for the line tangent to the graph of f at x equals negative 1. We know the form of an equation of a tangent line is this. We've seen it a bajillion times. We keep forgetting it, but that's okay. We just need to practice to the 100th power. So they tell us that a is negative 1, right here. They also tell us f of negative 1 is 2. Already, we're like 2/3 done. We have a, we have f of a, we just need to find the derivative at a. So the derivative, they give us as dy dx. So we're going to plug in, instead of just an x value, an x and a y value, the negative 1 and the 2 into the derivative. So when we do that, we get 2 as our final answer. That's what f prime of a will become. So we substitute, we get y minus 2 equals 2 times x plus 1. And this is what they have in the answer key. They just write the slope is 2, so this is the line. And it's 1 point. 1 point for this equation. So again, for the differential equation and slope field problems, do the slope field, do the particular solution first, and then go back and do anything else that's there. Because 1 point is not worth struggling for 5-6 minutes over. This is the one that you should struggle over because it'll give you the most points. Find the solution, y equals f of x, to the given differential equation with the initial condition f of negative 1 equals 2. Alright, we write the equation. We separate. The y squared goes to the left. The dx goes to the right. And I'm going to write these fractions a little bit differently. We can always pull them apart when we integrate. So I'm going to write 1 over y squared dy and negative 1 over 2 times x dx. I'm also going to rewrite 1 over y squared. I think you all know what I'm going to do. Y to the negative 2 instead, so we can do power rule. When we integrate, find the antiderivative, we get negative y to the negative 1, and then here we get x squared over 2, leaving the constant there, plus c. Rewriting this, negative 1 over y equals this, and I'm actually going to apply the initial condition right now. It's going to be messy fractions, but in this problem, like no matter what we do, we're going to get messy fractions. So let's just do it now. If we plug in 2 for y and negative 1 for x, this is the equation we get. Let's simplify it. Negative 1/2 equals negative 1/4 plus c. We add 1/4 to both sides, and we get c equals negative 1/4. Now we're going to rewrite this equation with c equals negative 1/4. Notice that there's negatives everywhere, so we can multiply everything by negative 1 so that everything is positive now. And now, this is where students make the silly mistake, because you're like, okay, I got this. I did all this work. Y equals 4 over x squared plus 4. We can't flip each side. If we flip 1 over y to make it y, we have to flip everything on the left, on the right side, but it's 1 over everything. So it's y equals 1 over all of this stuff. And if we do some fancy fraction stuff, we can get this as 4 over x squared plus 1. And I want to remind you that if it's in an equivalent form, you're good, but it has to be in the form y equals. So you can't stop here to get full credit. You have to get y equals for this solution, because it says find the solution y equals f of x. You don't need this last step, but you do need to say y equals 1 over blah 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 blah. Okay, that was a lot too. The initial condition was harder than the last one. I don't think the solving was as difficult as the last one, because we had e to the x, natural log, a whole bunch of stuff. This one we just have to worry about fractions, which I don't know, might be even worse. It depends on the student. So let's see how many points we get for this one. We get 1 for the separation, 2 for the correct antiderivatives, again 1 for using the initial, remembering c, 1 point for remembering c, just plus c, 1 point. 1 point for using the initial condition, and 1 point for solving for y. So even if you get stuck there, you still get 5 out of 6 points. That's amazing. Free money, free points. Really, really good. We're going to do some more of these in class this week. If not this week, then definitely next week. We're going to play around with the subfields that we made too. So your goal for these questions is to get at least 5 points. I may even bump it up to like 7 points. You should get 7 out of 9 points for these problems. Alright, see you in class.